Okay, we will solve the following exercise. The exercise is the number 2.6. The angle alpha, and in this case this Greek letter is called theta. The angle theta is equal to 50 degrees. Graphically determine the magnitude of the vector RIC. So this is the vector that I require. I have these two magnitudes, and the only thing that I have to say, or the only thing that I have to obtain here is this magnitude, this length. Okay, so what I'm going to do here is, well, an advice that I can give to you is that always use the diagram that the exercise is given to you, because it is easier and it is faster for you for when you want to solve the exercise. Okay, so right here what I have to do is to create triangles closing the entire shape. Alright, so right here I have one triangle, two triangles, and three triangles, and I have the value of theta. In this case, this is equal to 50 degrees. 50 degrees. Okay, so the only thing that I have to do right here is to find either these two values. For example, I'm going to call this value x, and I'm going to call this value y. I could look for the two of them, and right here I'm going to create one value that is called, I'm going to call c. Okay, right here as you can see I have a 90 degrees angle, and right here I have a 90 degrees angle. So let me begin creating the equations that I need. The first equation that I'm going to create is by using this triangle. So in this case, RAB is equal to the square root of y to the second power plus x to the second power. This is called the Pythagoras theorem. Okay, now I have two incognitas and just one equation, so this equation cannot be solved yet. Well, what I can create right now is that RBC is equal to the square root of y to the second power plus c to the second power as well. This second equation comes from this second triangle. And I'm going to create one last equation that allows me to use, maybe in this case, the angle. Okay, because I have this angle right here. So one thing that I can do right now is to say that the sine of the angle theta is equal to y divided by RAV. Okay, so I can get finally this value. With this value, what I can do is to use it in this equation. Then I'm going to be able to find c, and with c, and then I'm going to use one last equation for me to find x. So cosine of theta is equal to x divided by RAV. Okay, so that means that I do not need this equation. Okay, because I have this one, and this one, and RAB AC, I'm sorry, the one that I require is equal to C plus X. Okay, as I just said, I'm going to use this equation for me to find the X value. And I'm going to use this equation for me to find this value, and I'm going to replace it in this equation for me to find this. Once I have C and X, I'm going to be able to find RIAC. Okay, so this is telling me that X is equal to the cosine of theta multiplied by RAV. That means that X is equal to the cosine of 50 multiplied by RAV, 60 millimeters. Okay, X is equal to 38.5672 millimeters. I'm going to use 4 significant digits after the comma. Okay, I have my first answer right here. Now I'm going to look for Y. Okay, Y is equal to the sine of 50, in this case theta, multiplied by RAV. Okay, so I just have to change this, and RAV is still 60 millimeters. Okay, so this is equal to 45.9626 millimeters. With this equation, I'm going to solve this equation. So I'm gonna use green for that. RBC is equal to y to the second power plus c to the second power. That means that RBC evaluated to the second power is equal to y plus c. That means that RBC, okay, I'm looking for c. RBC minus y plus, okay, is equal to c to the second power. That means that c is equal to RBC is 150 millimeters over to the second power minus 45.9626 evaluated to the second power. Okay, I have a mistake right here. Should I think so? So I'm gonna use parentheses right here. Okay, I think that's not a mistake, because I'm using the parentheses that I need. Okay, let's use it as value, and if that's incorrect, we're going to check on that later. Okay, 0.4394 millimeters. Okay, so right here I have that. Let me check this value. I think it's incorrect. It has to be incorrect. Oh yeah, because right here I'm looking for this value, and I have to look for this value. Okay, so I can do this. That's right. So I just have to the square root of the answer that I just have, and C is equal to 142.7845 millimeters. Okay, so that means that the answer that we need, which in this case is RAC, is equal to X plus C. RAC is equal to this answer plus 38.5672. This is equal to 181.3517 millimeters. Okay guys, there is one way in which we can check that this answer is correct, and that way is using a software. In this case I'm going to use CATIA V5. Remember that you have within the channel different tutorials that teach you how to use this tool. Okay, right here I'm going to start a mechanical design, a part design. Then I'm going to create a shape that we just did. The align tool. Right here I have a line, right here I have a line, and right here, sorry. And right here I have a line. This line must be horizontal. And right here I have a length. Right here and right here. And right here I have an angle. This is telling me in pink that I have over constrained the piece. So this has to be created as a reference, so it only shows but does not change anything. Okay, but this is not the one. The one that I need is this one. Okay, I mean, this is the length that we don't know, the length that we require. Okay, this one. So I'm going to use this tool. This angle is 50. This length is 150. And this length is 60 millimeters. Okay. And as you can see right here, I have the answer. 181.352. So as you can see right here, this could be rounded off, or approximately 181.352. Why is that? Because I'm approximating this value to the next one, in this case the number 2. Okay guys, this is how this exercise could be solved and reviewed.